Alright, so this is our last lesson of Unit 0, and today we're going to be focusing on naming compounds, also called nomenclature. First, we need to look at the difference between covalent and ionic bonds and just kind of review that. Because remember, we have different rules for naming a covalent compound versus an ionic compound. So we need to be able to tell the difference. So remember, chemical bonds are just forces that hold atoms together within a molecule or compound. When we have a covalent bond, two or more atoms are sharing electrons. And when we have an ionic bond, we have two atoms that have become charged. They become ions. And so it's that force of attraction between their opposite charges that holds them together. So covalent you can think of as just sharing electrons. If we have a group of atoms that is covalently bonded together, we call that a molecule. And that could be atoms that are the same or atoms that are different. Ionic bonds are just that attraction due to opposite charges. So an ion is an atom, or it could be a group of atoms with a positive or negative charge. For example, sodium has a positive charge when it becomes an ion. Chlorine has a negative charge when it becomes an ion. We get an ionic compound when those opposite charges attract. And so like NaCl, sodium chloride, is an example of an ionic compound made up of oppositely charged ions. We also can have polyatomic ions. These are groups of atoms that have a charge overall. They are listed on page 65 in your book. You will need to memorize these polyatomic ions. We will have a quiz over them. And on the AP exam, you will need to know these. They're not just going to be given to you. All right, so let's look at naming compounds. So let's start with ionic compounds. The first rule is that the cation, the positive ion, is always named first, and the anion or the negative ion is always named second. The cation takes its name from the name of the element, and it just stays the same. So sodium with a positive charge is still sodium. Calcium with a 2+ charge is still calcium. The anion takes the root of its name, but then changes the ending to IDE. So Cl is chlorine, but when it becomes charged, we change that ending to ide, so it becomes chloride. Sulfur, when it becomes charged, becomes sulfide. And so those endings kind of change where they're placed. It's just kind of something you have to get used to, where you cut off the ending and add the IDE. And that just comes with practice. So we need to find the name for Na2O and write the symbol for magnesium nitride. So in order to write the name, we keep the name of the cation. Na is sodium. And O is oxygen. But remember, for the cation, we do not keep the ending of the name. We change it to IDE. So we're going to change oxygen's ending to IDE, and we wind up with sodium oxide. In order to write the symbol for magnesium nitride, we need our periodic table. So we know magnesium's symbol is Mg. And when we look at the periodic table, we see that magnesium is in the second column, which means it's going to have a 2+ charge. It's an alkaline earth metal. Nitride comes from nitrogen, so the symbol there is N. We locate that on the periodic table, and this column has a -3 charge. So our nitrogen has a 3- charge. The key here is that we have to cancel out the charges, and if we look at this, 2+ and 3- does not cancel each other out. Right now we don't have enough positive charges, so I'm going to add another magnesium. Now I have 4 positive charges, 2 + 2 is 4, and 3 negative charges. So now I don't have enough negative charges. I'm going to add another nitrogen. Okay, so I still have 4 positive charges, but now I have 6 negative charges. So I need to add another magnesium now because that one doesn't have enough. So now I have 2, 4, 6 positives and 3, 6 negatives. So those cancel each other out. And so to write the formula, I count up how many of each I used, and that becomes a subscript. So I had 1, 2, 3 magnesiums. So I'm going to put Mg with a subscript of 3. And I used 2 nitrogens, so I'm going to put N with a subscript of 2. All right, so if the cation is a transition metal, things are a little bit different. First, we have to figure out the amount of charge that the anion has based on the periodic table. And then we can multiply that by its subscript to find out the total negative charge in our ionic compound. The ionic compound always has to be neutral, so the cation has to cancel out whatever the total negative charge is. So the cation has to have like the same amount of charge, but it's just going to be positive instead of negative. To show what the charge on the transition metal is in the compound name, we write that charge as Roman numerals in parentheses. And we have to do this because transition metals can have more than one charge. Like iron could be positive 2 or positive 3. We don't know what it's going to be unless we're told. And so we have to figure that out based on the anion. And then when we name it, we have to put that in the name, or else just by looking at the name, there's no other way to tell. In this case, the anion stays the same though, like the IDE rule is still valid for the negative ion. So to name FeBr3, we have to recognize that Fe is a transition metal, and so it does not have a set charge. So in order to figure this out, we need to look at bromine, our anion. And when we look at the periodic table and find bromine, we see that it's in the halogens, which means it has a 1- charge. When we look at our formula, we see that there are 3 bromines. They each have the same charge. And so our total of our negative charges is -3. We only have 1 iron, but we know that it has to cancel out this -3 charge. And so it must be a +3. So when we go to write the name, we have to include this in the name to show which iron we're talking about. So we would write iron and then a parentheses 1, 2, 3 for this +3 charge, and then bromide because the anion, remember, it changes its ending to IDE. In order to write the symbol, it's pretty much like a regular ionic compound. Tin is SN, and we don't even have to look at the periodic table because it tells us right here that the charge is 2+. Nitrogen is N. When we look at the periodic table, we see that that is 3-. And so we basically have to go through again and add ions until they cancel out. So now we have 6 positives and 6 negatives. So our formula would be SN3N2. If we have polyatomic ions in our ionic compound, the name of the polyatomic ion just stays the same. We don't have to change it. We don't have to put Roman numerals or anything. The tricky part with polyatomic ions is really just learning their names. So remember, you do need to memorize these for the AP test. We will have a quiz on them, but you will need to know their names, their symbols, and their charges. So a couple of just tips for helping you to remember them. Typically, they come in groups, like nitrate and nitrite are NO3 3 and NO2. So if there's a group of polyatomic ions like that where they have similar names and similar formulas, you can know that the one with smaller number of oxygens will end in ITE, and the one with the larger number of oxygens will end in ATE. So nitrate, ATE, has 3 oxygens, while nitrite, ITE, only has 2. And there's the example there. If there's more than 2 members of the group, we can use prefixes. So an example of this is the chlorite group. So in the middle here, you can see we have ClO2, which is chlorite, and ClO3, which is chlorate. If we have less than 2 oxygens, we have fewer, we have ClO, we change it to hypochlorite. So hypo is put as the prefix to tell us it's the least amount of oxygens. If we have more than our 8 group, then we put a per in front of it. So ClO4 becomes perchlorate to show us that it's the most number of oxygens. When we're naming a compound with a polyatomic ion, the name of the polyatomic ion just stays the same. We can tell something has a polyatomic ion in it, even if we haven't memorized them all yet, because there will be more than 2 capital letters in our formula. So remember, the capital letter tells us that it's a new element. And so here we have BaSO4. That means there's 3 different elements, which means one of these combinations has to be a polyatomic ion. In this case, our polyatomic ion is the SO4. So we can name Ba, which is just barium. And since it's the cation, the name doesn't change. And then SO4, once you have those memorized, you'll know, but for now you can look it up in the chart in the book, but SO4 is sulfate. And that's it. To write the formula, it's very similar. We know magnesium is Mg, and when we look at the periodic table, it has a 2+ charge. Nitrate is a polyatomic ion. We can tell that it's not nitrogen because the ending is ATE. If it were nitrogen, the ending should be IDE because that's what we changed the anion to. So we know this is a polyatomic ion. We can look that up and see that nitrate is NO3-. Okay, so we look at our charges, we see that we have more positives than negatives, so I can add another nitrate. Now I have 2 positives and 2 negatives, so I can go ahead and write my formula. And in this case, I'm going to put this polyatomic ion in parentheses because there's more than one of them. If I didn't put that parentheses there, it would be very misleading as to what that 2 means. And so that needs to happen in order for it to be clear. Okay, so for covalent compounds, we basically just write them in the order they're given. So if we're given the formula, the first element of the formula is named first, and we use the full element name. We don't change the endings. For the second element, we name it just like an anion, so we want to change that ending to IDE. However, in covalent compounds, we also need to add prefixes to show how many of each atom there are, because with ionic compounds, we can figure that out based on their charges, but with covalent compounds, there are no charges, and so we need to have that given to us in the name. The one quirk about this is that if there's only one atom for the first element in the compound, we do not use a prefix. So that prefix for having only one atom is mono, but that is never used for the first element, only for the second one. Naming covalent compounds is all about the prefixes, and the prefixes come from the subscripts within the formula. So here we have B, which is boron. and it has a subscript of 2. And so I'm going to put a prefix of di in front of it. So it'll be diboron to show that there's 2 of them. Our second element is oxygen. Again, just like ionic compounds, the ending must change to IDE. So it's going to be oxide. So we added that and that. And then to show how many of them there are, we need to put a prefix for 3. The prefix for 3 is tri. So we have diboron trioxide. When we're writing the formulas, we use those prefixes to tell us what the subscripts should be. Arsenic is AS. Since there's no prefix and it's the first one, it just means there's one of it. So we leave that blank. And then fluoride comes from fluorine, which is F. And penta means 5, so there's 5 fluorines. Naming acids is a little bit different than naming ionic or covalent compounds. So there's 2 types of acids. There are acids with oxygen and acids without oxygen. All acids have the same cation. They all have hydrogen as the positive ion. And then they have a negative ion with it. So if that ion is just a single element, it fits into the no oxygens category. And so we take that anion and we change the ending to IC, and we add a prefix of hydro to the beginning. This prefix of hydro is what tells us that there are no oxygens in this acid. So for example, HCl is hydrogen and chlorine together, right? And so we don't need to name the hydrogen because it's the same for every acid, but we look at the chlorine for the naming, and we change that ending to IC, and then we put hydro in front of it to show that there was no oxygen in this formula. So we wind up with hydrochloric acid. If the anion does contain oxygen, then there's 2 possibilities, and that depends on the ending of the name of the anion. So in this case, in order for it to contain oxygen, it must be a polyatomic ion. So if our polyatomic ion ends in ATE, we add IC at the end, but we do not put hydro at the beginning. If the anion ends in ITE, then we change the ending to OUS, and we still put no hydro. So H2SO4 is an example here. SO4 is the polyatomic ion sulfate. Since it ends in ATE, we change that ending to IC, and we get sulfuric acid. Remember, no hydro prefix. So we could also look at H2SO3, where SO3 is sulfite. Since it ends in ITE, we change that ending to OUS, and we wind up with sulfurous acid. When we're naming acids without oxygen, we will always have hydrogen as our cation, and then we'll have some sort of anion. Usually it'll be a single element. So because hydrogen is always the cation, we don't name it in acids. We just look at the anion. In this case, our anion is nitrogen. And so we change the ending of nitrogen to ic. So it'll be nitric. We also put a prefix in front of it of hydro to show that there's no oxygens in this formula. And then we end it with acid. So H3N is hydronitric acid. For this one, hydrofluoric acid, for any acid, remember we have a cation of hydrogen. So we know we have H+. We look at the name here to figure out what our anion is. Well, fluoric comes from fluorine. And we know this is just an element. It's not a polyatomic ion because of the hydro. There's no oxygens here. And so then we just look at our charges. We have one positive, one negative. Those cancel out, so we can just go ahead and write that as HF. When we're dealing with acids that have oxygen, there will always be a polyatomic ion involved. So in this first one, our polyatomic ion is the NO3. That is nitrate. And in order to change this to the name of the acid, we remove the ATE ending and change it to ic, nitric. And then we put acid after it. There's no prefix in this one to show that this one has an oxygen. So that's done. For changing it to the symbols, again, we recognize that there's no hydro, so there will be a polyatomic ion. Our cation is still H+, as usual. And then we need to figure out which polyatomic ion this is. Phosphoric came from phosphate. So I find phosphate is PO4 3-. And so I basically just have to balance these out. I have 1 positive and 3 negatives. So I just keep adding positives until I get them equal. And then I write my formula. One last thing to name that we didn't really cover in baby chem is hydrates. Hydrates are ionic compounds that can trap water within their structure, and so they can gather these water molecules to stick with them. And we have to show how many water molecules each ionic compound has in the formula and the name. So in order to write the formula of a hydrate, we write the formula of the ionic compound as we usually would, following whatever rules we need to, whether it has a polyatomic ion or a transition metal or whatever. We just follow those rules. And then we write a dot and the correct number of waters. So if the name says dihydrate, then we would put a dot and 2 H2O because di means 2. When naming a hydrate, we just name the ionic compound as we normally would, and then we'll use prefixes to help us name the hydrate portion. So MgCl2, we have magnesium. Magnesium is not a polyatomic ion, so we do not, or not a transition metal, I'm sorry, so we do not need the Roman numerals. So we have magnesium, and we have chlorine, which is going to change to chloride. And then to name this part, the H2O is just called hydrate in these. So we don't call it water, we don't call it dihydrogen monoxide, we call it hydrate. It's just kind of a special situation. And we put a prefix in front to show how many there are. So 7, the prefix for 7 is hepta. So this would be magnesium chloride heptahydrate. The hepta comes from the 7, the hydrate comes from the H2O. In order to write the formula, we take the name, sodium sulfate decahydrate. We can focus on the ionic compound part first. So we have sodium, which we know is Na+, and sulfate, which is one of our polyatomic ions, it's SO4 2-. These do not cancel out, so we have to add another sodium, and we get Na2SO4. Now on to the part about the hydrate. Remember, hydrate means H2O, and the prefix is the number. Deca, like decade, is 10. And so we would write a dot after our ionic compound. We'd put 10 and then H2O.